Hello, I'm Laura Lewis. Welcome to Calculating Density class. So we're going to talk about learning aim today. So rearrange and substitute values into the density equation. Understand how to use volume equations for three-dimensional shapes, so regular three-dimensional shapes, and apply the equation to exam style questions. Okay, so let's have a look. The density itself can be described by mass per unit volume. So it's the amount of mass in a given volume. Okay, so obviously that's the most important thing to understand. You can kind of guess the formula from that. So density is in kilogram per meter cubed, could be centimeters cubed that we'll look at, but meters cubed or centimeters cubed. Mass is in kilograms, volume meters cubed. It could be centimeters cubed as well. Okay, so some smaller objects, sometimes that's in centimeters cubed. Okay, but you have to look at the units. So we'll get on to questions where you look at the units to see what you need to do with that. So example of density, so an ice cube has a density of so water has a density of 1 gram per centimeters cubed. Okay, so and lead has a density of 10.7 grams per centimeters cubed. So a cube of lead would be 10 times, but approximately 10 times denser than an ice cube. So you can kind of imagine that if you picked up the same volume of each one, the lead would have a bigger mass, so it would weigh a lot more. Okay. So often density is shortened to this rho. Okay, it's a Greek letter rho. Is mass over volume. It has the shortened form. So density is mass over volume there. Okay, so when we say regular solids, we mean things like this. Okay, so you have a sphere. So obviously it's three-dimensional. It's hard to draw a sphere. So a sphere is like a ball. Okay, or a planet could be a sphere. So it's 4/3. Okay, maybe we'll put times in there. So 4/3 times pi times r cubed. A lot of time this is 4/3 pi r cubed. We look at the cubed all the time. So when you get a volume, it's always cubed at the end like that. A cube itself is, you only need to know one side because a regular cube, it has to get the name cube, it has to have the same side. So L, L, L. So it can only tell you one side, and it's L cubed. So it's L times L times L. Okay, the cuboid, I'm sure you're used to, the volume is width times length times height. So regular solid, so this is the volume calculations. Okay, volume calculations. So we get on to density in a moment. So look at the volumes first, in case people have forgotten. Yeah, it's that sphere one that catches people out. So in case obviously you need to convert from meters cubed to centimeters cubed or vice versa, you have to be quite careful with this because this is where people get this wrong. So 1 meter is 100 centimeters. So a meter rule we use at school is 100 centimeters. So the volume, this is a cube. It's quite a big cube, 1 meter by 1 meter by 1 meter. Its volume would be 100 centimeters. So these are centimeters by 100 centimeters by 100 centimeters. That would actually give you 1 million centimeters cubed in 1 meter. Okay, so that's if you need to convert between the two. You might only get that in higher exam questions, possibly, things like that. But just in case you need to know that. We won't be doing too much today of that. So practice. So a cube of side 5 centimeters has a density of 6 grams per centimeters cubed. What is its volume and mass? So the volume, easy, it's a cube, we're told, so it's 5 cubed, so 5 times 5 times 5 would be 125 centimeters cubed. So now we need to work out its volume. So density, we were told, is 6. Okay, so that's 6 grams per centimeter cubed. Mass, we don't know. We know its volume. So all we do is multiply that by that. Okay, 125 centimeters times 6, 750 grams. Okay, so we've got grams per centimeter cubed, centimeters cubed. No conversion was needed with that one. It's all consistent units. Okay. Sphere this time. So a sphere has a radius of 4 centimeters, like a ball, probably about the size of a cricket ball. What is its volume? So volume of sphere, 4/3 pi r cubed. So doing one thing at a time. So 4/3 is a number, you put into your calculator, times pi, also on your calculator, times 4 cubed. We'd get 268 centimeters cubed. So taking the same sphere, what is the density of the sphere? If the mass is 500 grams, okay? So volume from before, 268 centimeters cubed, mass 500 grams now. So again, we've got density is mass over volume, mass 500 grams over 268 centimeters cubed. Careful with the units here. So it's 1.9 grams per centimeter cubed. Again, no conversions there. So what if the object is not regular? Okay, like if you could get a question like a rock or a potato. Okay, so you wouldn't do a calculation like we did before straight away. So all you need to do, okay, it's quite an easy exam question if you get this, is by measuring it. Okay, you just talk about how you measure it. You don't have to actually physically do it, but you have to talk about how you do it. So you find the mass, place the object on a balance, that's scale. Okay, so we put a balance in science. So you find its mass. Okay. To find the volume, place the object in the measuring cylinder. We've got a big one for a potato, depends how big the potato is. Put it in the measuring cylinder, filled halfway with water. So you probably fill that to about here. Okay. And obviously, that's before you put it. You put it in. If you look at the volume before you put the object in, and then you look at it after you put the object in, because obviously the water is going to rise with the object in it. So it's this measurement here. Okay, so it's this measurement. And that will be in centimeters cubed. Okay, so you may think, okay, sometimes it's in milliliters, but it's because 1 milliliter of water is 1 centimeters cubed, like before the ice cube. So hopefully that will be helpful for you. Thank you for listening. Hope to see you in another video. Goodbye.